Welcome back. I'm talking to Roger Anderton about the history of physics, and in particular Boscovich. We've got a picture of Boscovich on the screen there. Just tell us a little bit about him, Roger.
Yeah, in the 18th century, the Catholic Church was trying to recover from having persecuted Galileo, but they had the priests, the Catholic priests. Some of them were still looking into the science issues of what Galileo was talking about, and so Boscovich is one of the top men they had looking into this issue. And I think this is supposed to be him, but he was looking at Newton's physics. And so he was what he considered to be the first Newtonian on the continent of Europe, and he advocated Newtonian physics, and a large part due to his influence, that he managed to get the Catholic Church in the European countries to accept Newtonian physics.
Right.
After having banned that sort of physics with Galileo.
His life overlapped a few years with Newton.
I think so, yeah.
So, but he's certainly after Newton.
Yeah. The conflict at the time that when Newton died, which was left, was they had a conflict between Newton and Leibniz over physics. So you had people, and you also had Newton not having a complete theory. It didn't unify everything. And so Boscovich was into combining the ideas of Newton and the ideas of Leibniz and making a unified theory.
Right.
Hence why this is a unified theory. And what he was talking about was a sphere of influence around objects, which we can interpret as a field. So he was talking about a field influencing other objects. So it's a unified field he was talking about.
Right.
It's the first unified field theory I know about.
All right. Do you want to expand on that a little bit, Roger?
What my emphasis has been upon is translating his work, because most of his work has not been.
Yeah. This is a booklet that Roger has translated.
This is a chemist in Serbia who has worked on Boscovich's theory, and he's very impressive. He's got a lot of qualifications.
And you've translated.
He's written 60 papers or so on Boscovich.
What's his name?
Science Journal. He's Dragoslav Stokovich. So this is modern work on Boscovich's theory.
Right, and this guy's alive today. Right.
And he sort of like I think he's advocating that it's a unified theory of physics as well, because he ties it into quantum physics. He's done the work.
And you've translated his document into English. He's saying that there is a field of influence around objects or matter, and that's characterized by this graph of his.
The graph,
which is a force distance graph.
That is the force. That's how he's displaying the force between particles. There's an attractive force and there's a repulsive force between particles, and it's what we now say is a field. So there's a field for repulsive force and a field for an attractive force. And with Newton, he was only considering gravity as being attractive.
Right.
So with Boscovich, you've got more than just an attractive force. You've got a repulsive side to it.
So if we look at that graph there on the screen, we see that the vertical axis is force and the horizontal axis is distance. Yes?
Yeah.
So what that's saying is, as we move further away, out say from the center of a particle, the force will pull you back, then it'll push you away. As you go further away, it'll pull you back again. As you go further away, it'll push you out again. So it's varying. So that would lead one to believe that there are certain areas that you'll be forced into, i.e., around an atom.
Yeah, that's right.
So is this defining the orbits of an atom then? This graph?
Yeah, Niels Bohr was working from Boscovich's theory when he constructed the hydrogen atom. He was considering electrons going around the nucleus, and there was allowed and forbidden orbits. There was places where the forces was balanced, and there's places where the forces weren't balanced. And where they were balanced, there was an allowed orbit of the electron around the atom, or the atom's nucleus. And when it was not in that region of area space, it would be unbalanced force, and so it would either be pushed further in would push further out. It's sort of forbidden areas around. That's the quantum levels of the atom.
And you can have so many on each level. If I remember from my chemistry, 2 and then 8, and then it gets a bit weird.
Yeah, that is a bit more on top of it from Pauli's exclusion principle and things, I think. But the basic idea of allowed and forbidden orbits around the nucleus is coming from Boscovich with his force theory.
So Bohr then, who came up with this different levels of electrons in the atom, do you think he got his theory from Boscovich?
Yeah, he did. He was working for Boscovich's theory.
Right. So why is it called the Bohr atom rather than the Boscovich atom then? Because is this all part of the Whig history thing?
You caught me. I don't know why they do that. If you're being more accurate, you probably call it the Bohr-Boscovich atom, but they've just called it the Bohr atom.
Right. All right. Well, here's a question then, Roger. So, if we come outside of the area of an atom and we get to, say, electromagnetic or gravitational forces, does Boscovich include gravity, for example?
Yes, gravity comes into it.
So can you show us that on? I mean, is that part of that same graph, or is that a different thing?
I'm not really got it shown on the diagram, but I'm in contact with loads of people, and one of the people is working out what is the characteristics of the graph. So I've got this person who's Augustus Prince, who's retired from Brookhaven National Laboratory, and he's looking into complicated issues like that.
Right. Okay.
So that should be hopefully published soon. It's supposed to have been coming out from a conference I attended.
So you would like to see Boscovich named as one of the pillars of physics in physics education, would you?
He was.
He was. Yeah.
I mean, the Catholic Church says that Boscovich is the father of atomic theory.
Right.
And he was the theory which the atomic physicists were using during the Manhattan Project.
Right. Right. Rather than Einstein.
Yes, I think so.
Because you were telling me earlier on that the people who were developing the atomic bomb didn't really get on with Einstein. I mean, wasn't Einstein a bit of a pacifist? Not that there's anything wrong with that, but
during World War One, Einstein was a pacifist. He wasn't. That's why the other Germans fell out with him. He wasn't patriotic, but during World War II, he sort of like gave up pacifism and decided you had to fight Hitler.
Right.
So he changed his mind on that.
Right. Okay.
But he wasn't involved in the Manhattan Project, which is the atom bomb project.
Right.
Other than writing a letter to the president saying, look into building the atom bomb, because he was afraid that Hitler was going to try to build one. Most of Boscovich's work hasn't been translated into English, so I'm trying to translate it. And you get, this is the Latin, so that bit there is using the word quantum, and quantum is a Latin word, so he is saying there quantum physics. But if you're looking at what the word quantum means in Latin, it comes out roughly meaning as much as. So it is a bit difficult to understand what is meant there. From a modern perspective, we would think of quantum physics, but as much as physics allows, he's saying. As much as physics allows, he's talking about Newton demonstrating something, a proposition, and it says as much as physics allows. So quantum physics is coming from the writing of Boscovich in the 18th century.
All right, Roger. Well, we're going to go for another break, and when we come back, we're going to have a look at a very brief clip from a lecture from biologist Rupert Sheldrake.